Section 8.3, Algebraic solutions to trigonometric equations. Our objective is to solve trigonometric equations algebraically. Now, in section 8.1, we solved trig equations using our graphing calculator. So now we're going to algebraically do this, and we can use our graphing calculator to help our check our answers. So when we're solving these trig equations, notice that the original equation does not have an inverse in it. So that means that there are many possibilities that we can have when solving these equations. So this table just kind of gives us a little helping hand in when we're solving the equations and what we should do to find the solutions. So if we look at the sine of x is equal to some number, and we're going to call that value c. If I wanted to figure out what my solutions are going to be for when the sine of x is equal to this value of c, we can do a couple of different things. So remember right here we have our sine graph. If I have values of c that are in between -1 and 1, notice that like here, if my answers were positive c values, then I would have two solutions in between 1 and -1. If it's negative answers, I also am going to have two solutions. So to find those two solutions, we're going to use our inverse on our calculator. So we know we can do x would be equal to the sine inverse of c. And then remember that we have multiple answers that we can have because this graph is going to keep on repeating itself. So plus the period of the function 2 pi n. We're not done though, because we also have another solution for which we can get these values. So the question is, how do we get the other solutions that we have? Well, there was an identity that we didn't really memorize, but it's the sine of x is equal to the sine of pi minus x. This is the identity that we're going to use in order to help us find the other solutions. So if you think about it, if I have my unit circle values, let's say our value of x is pi over 4. So then if my sine values are positive, then the other value that's going to give me a same solution would be over here to get that root 2 over 2, is if that's what we were solving. So then over here, notice that if I do pi minus pi over 4, I get 3 pi over 4, and we know that because it's on my unit circle. And so that would give me my other value where, and if this was the equation, the sine of x is equal to root 2 over 2. So let's say we were solving that equation. So then that's where we got the pi over 4, and then 3 pi over 4 plus 2 pi n, where n is integer. So that would help us find all of our solutions. So to find the second solution, which I'm going to call x2, so this is x1, x2, we do pi minus the sine inverse of c plus 2 pi n. Now, when we're equal to a c value of 1 or -1, so if I have the sine of x is equal to 1, or if it was -1, notice that 1 only has one solution because it only hits once on my graph. So we know from our unit circle that this would be x is equal to pi over 2 plus 2 pi n. If it's -1, then x would be equal to 3 pi over 2, or instead of saying 3 pi over 2, we can also use negative pi over 2. So in this case, negative pi over 2 plus 2 pi n is what I'm going to use. And again, you can use 3 pi over 2. It doesn't really matter. So then for the next one, if it's above 1 or -1, we'll notice above 1, you would not have anything on your graph, and below -1, there would be nothing on my graph because it's a unit circle. So in this case, there would be no solutions. So then let's go ahead and do where the cosine values are equal to c. So if c values in between 1 or -1, we're going to now have two solutions. So I know one of my solutions, x equals the cosine inverse of c, and then plus the period 2 pi n. But how do we get the other solution? Well, remember that our graph also continues backwards, and so if I were to find some solution here, it would also be the same solution there on my graph, since we're going backwards. If I, let's say, wanted a value of where the cosine of x is equal to 1/2, so then I could do this value would be the same as this one plus my period of my function. So if you recall, on your unit circle, where do I have and positive values for x? It would be on the right side of my unit circle. So I can do this value and this value are going to be the same. And notice that I can just do the negative answer for that. So and that's because of the negative angle identity. So the cosine of negative x is equal to the cosine of that angle. So by that property, x would be equal to the negative cosine inverse of c plus 2 pi n. When c is equal to 1, then remember that our solutions start at 0, so x would be equal to 0 plus 2 pi n, or you can just write that as 2 pi n. For negative 1, our solutions would be x is equal to pi plus 2 pi n, and then no solutions. And for the tangent graph, remember that this is my x and y axes. My graph looks like this. So remember, we only have one solution anytime we are solving for c. So in this case, the only solution we have is x is equal to tangent inverse of that c value that we're trying to find. Or not, the c value is what we're given, we're trying to find the x. So plus the period of my function, which in this case, remember for tangent, it's different, it's just pi. So that's kind of nice overall picture of how we solve these equations. So let's go ahead and start to solve some. So for this first part, it says solve each equation, round your answers to the 4 decimal place. So we have the cosine of x is equal to 0.6. So graphically, if you think about this, 0.6 would be somewhere in here on my graph. And so again, we know that we're going to hit here and here. So 2 answers for one length of my period of my graph. So in order to find the answers, our first answer is x is equal to the cosine inverse of 0.6. And if we do this on our calculator, you can just punch it in and you get your first answer. So x1 is equal to 0.9273 plus 2 pi n. So that would give me my first solution. So the second solution, instead of trying to figure out what this answer is over here, if I go backwards on my graph, this solution right here corresponds to this solution, and notice that it's the negative angle, so all we have to do is just do x2 would be equal to the negative of this answer. So cosine's nice that we don't have to really do much. You can just write plus or minus your answer plus the period of the function. So these are my cosine solutions. Now for sine, if I have the sine of x is equal to negative 0.075 and I want to find the solutions, for this one, negative 0.75 would be somewhere down here. So notice that it would hit here and here on my graph. So I have, again, 2 answers, and I know that because it's in between negative 1 and 1. So my values are going to be x is equal to the sine inverse of negative 0.75. And when I do this in my calculator, I get my first solution, x1, is equal to negative 0.8481 plus 2 pi n. And then for my second solution, remember we talked about that pi minus our answer gives us the second solution. So now if I do x2, this would be equal to pi minus the sine inverse of negative 0.75. And so on my calculator, I would actually type that in, and when I do, I get x2 is equal to 3.9897 plus 2 pi n. So this would be my 2 solutions. And again, notice it's different from the inverse trig equations that we were solving because those we were evaluating, and we only had one answer when we had a sine inverse in our equation. Now we're solving for multiple angles that we can have where the sine of x is equal to negative 0.75. So for the tangent, this one's nice because I know that tangent's only going to want to have one answer. So this would be the x equals the tangent inverse of negative 4 plus pi k or pi n. So then for this one, when you plug it into your calculator, and I forgot to mention, make sure you're in radian mode when you're doing these problems. So in this case, we would get x is equal to negative 1.3258 plus pi n, and that would be my only solution. So I want to go back to the first problem that we had, cosine x equals 0.6. So just remember when we did this before, we set it equal to 0 and plugged it into our calculator. And remember we said we know the period of this function because my b value is 1 would be 2 pi over 1, which is 2 pi. So my window we changed from 0 to 2 pi and we looked at the graph. So again, here are my solutions that I have. And even just to show you, if I do second trace value, I'm going to do the cosine inverse of 0.6. And notice that that will give me my first 0 that I had right there. And instead of finding this 0 on my graph, we did the plus or minus. But even to show you, I'm going to change my window to negative pi and hit graph just to get a bigger window. So remember our answers are just repeating. So this answer here, I know is going to be the same as this solution that we have right there. So they're going to be the same. And even just to show you, I'm going to do the value second trace, and I'm going to do value, so the cosine inverse, so negative cosine inverse of 0.6. So if I do that, notice that I get this value in my calculator. And if I add the period, which is 2 pi, so if I add plus 2 pi, you'll notice that I'm going to get this solution over here. So it gives us the same answers from when we did it graphically. Again, it's just a different way of finding the solutions. And so the reason that we add the period of the function is because remember that these solutions are going to keep on repeating with our coterminal angle, so plus 2 pi n or minus 2 pi n, depending where you are. So before we were only looking at the length of the period, so that way we didn't repeat our answers. So now we're just algebraically using the cosine inverse. So again, you can use your calculator to help you check, but do make sure you know how to do this using using algebra. So let's go to the next problem. So we're just going to do a bunch of these. So for the first part, it says solving other trig equations examples. So we're going to solve x equals, or x times the cosine of x, 8 times the cosine of x minus 1 equals 0. In order to solve this equation that we have here, we're going to use some algebra. So I'm going to solve for the cosine of x. So if I solve for the cosine of x, I add the 1 divided by 8. So I get the cosine of x is equal to 1/8. So if I want to find my solutions, I know that x is going to be equal to, because it's in between 0, or in between -1 and 1, I know it's going to be plus or minus the cosine inverse of 1/8 plus my period of my function, which I know is 2 pi n. So in this case, I know that x on my calculator when I do this is going to be equal to plus or minus, because that's going to be my two solutions, and it ends up being 1.4455 plus 2 pi n. And I suggest that you guys also plug these into your calculator as we're doing these so that you can check to make sure you're getting the same answers that we are getting. So these would be my two solutions, and of course I could check that using my graphing calculator. So for the next one, if we have something that we recognize, like I recognize this right here as being a value on my unit circle. If that happens, that means you want to get the exact value answer. Unlike when we had 1/8, I know that wasn't on my unit circle, and that's why I can use my calculator. So for this one, I have the sine of u is equal to √2/2. So I'm trying to figure out what angles give me √2/2. So you can think about your graph, or you can think about your unit circle, or you can even make a triangle if you like. So for this, I know that √2/2, the sign is positive, and where do we get positive sign values? In quadrant 1 or quadrants 2. So right here, I would have one answer, and I know that that is actually at pi over 4. So then the other answer over here to get √2/2 would be equal to 3 pi over 4, because it's pi minus your answer. So pi minus pi over 4 is 3 pi over 4 on my unit circle. Or again, you can think about your graph, so however you like to do that. So I know that u is equal to the sine inverse of √2/2. So we know that u would be equal to pi over 4 plus 2 pi n, and the second answer is going to be equal to pi minus that, which we know from our unit circle is just 3 pi over 4 plus 2 pi n. So again, anytime you have something that's on your unit circle, make sure you find the exact values of it. And if you wanted to, you could also think about making a triangle and then trying to figure out what kind of triangle we're working with. This would be a 45, 45, 90 triangle, and then solving to find your solutions. So let's go to the next one. For the next one, we can use substitution. So this one's a little bit different because we have the sign of 4x in our equation. So if I have the sign of 4 times my angle in my equation, well, that's going to be difficult to solve. So I need to use substitution to get it so that it's not the sign of 4x. I'm going to say, let u equal 4x. And I'm going to solve the sine of u is equal to root 3 over 2. And again, I recognize this from being on my unit circle. So if I have the sine of u is equal to root 2 over 2, well then I know that u is equal to the sine inverse of root 3 over 2. And so if I think about my unit circle, where do I get sine values that are going to be equal to root 2 over 2? Or root 3 over 2, excuse me. So root 3 over 2 I know is going to be up here, and I know right here because it's positive, so it's in quadrant 1 and quadrant 2. So in this case, I get u is equal to pi over 3 plus 2 pi n. And my second answer is pi minus that, so I know that pi minus pi over 3, we need a common denominator, so this would be 3 pi over 3 minus pi over 3, which is where we get 2 pi over 3, and we should have already known that because it's on our unit circle. So 2 pi over 3 plus 2 pi n. Well, these aren't my answers. Why are these not my answers? Because I let u equal 4x in the beginning, so that means that I need to take out this u that we have right here, and I need to put back in what I substituted out. So I need to replace this with 4x, and then I need to solve for x. So how do I solve for x? It's like dividing by 4. So if I divide everything by 4, it's really like multiplying everything by 1/4. So if I have pi over 3 times 1/4, I get pi over 12. So I know that in this case, x is going to be equal to pi over 12 plus 2 divided by 4 is 1/2, so that would be pi over 2n. And this solution right here, when I divide everything by 4, so each term has to be divided by 4. So 2 pi over 3 divided by 4 is the same thing as 2 pi, 2 pi over 3 times 1/4. So that would be 2 pi over 12, which is pi over 6. So x is equal to pi over 6 plus 1/2 pi, which becomes pi over 2n. So these would be all of my solutions that I have for these two equations. Now, you can even go back to the beginning. Remember when we were doing this graphically? Graphically, we said we had to find the period of the function. So I'm going to check. My period, according to this, is pi. It should be pi over 2. So my b value in the equation is 4. So how do you find the period? You take your parent graph period, which is 2 pi, divided by your b value. So 2 pi divided by 4 is pi over 2. So that makes sense that my answers, I'm adding pi over 2. And if I even just do what we did in section 8.1 to graphically look at this, so I plugged it into my y equals, and then I'm going to go to my window. And remember, before we graphed it from 0 to the length of our period, which in this case is pi divided by, pi over n, pi divided by 2. And I know my key points are going to go and divide that by 4. So pi over 2 divided by 4 multiplied by 4 is pi over 8 for my key points. Remember, you divide your period in 4 equal parts. And if I hit graph, I have 1, 2 solutions. So those solutions should be pi over 12, which gives me my first answer, and I know the next one should be then pi over 6, just to check. And notice I get pi over 6. If I were to make the length of this window larger, maybe do 2 cycles instead of 1 cycle, if I add pi n to each of them, then I know I'm going to get multiple answers. So if I change my window instead to pi, because pi over 2 plus pi over 2 would be pi, and hit graph, notice I would have 2 cycles now. So then for this, if I do, just to show you, second trace value, I have pi divided by 12, which was my first answer. And if I add my period, which is pi divided by 2 to this, and hit enter, notice that gives me my second 0. So this one, the next one would be here, and that's why we have to add the period of the function. So that would give me second answer. So pi over 6 plus pi over 2 would give me this for the next answer. So that's why we have multiple places where we can be equal to these. And so these would be my solutions that I have. So then the next one, we have solve 3 sine squared x minus sine squared x minus 2 on the interval from negative pi to pi. So now it's specifically telling us we want specific answers. I don't want all of my answers. I only want answers on this interval. So you have to be very careful for when it says things like that. So for this one, I am going to, when I look at this, if I have 3 sine squared x minus sine x minus 2, this tells me I can probably factor that. So I'm going to check. So I'm going to let u equal the sine of x to make this easier. So I have 3u squared minus u minus 2 equals 0. So if I have this, I recognize that I can factor this equation. So this factors into 3u, I know this is going to be u, and so then I have to think of my factors. So 3u plus 2 and u minus 1 is going to be equal to 0. So then remember, when you solve these, we did this in algebra, we get 3u plus 2 equals 0 and u minus 1 equals 0. So here you would get u is equal to negative 2/3 and u is equal to 1. So then now if I use my substitution, I have to substitute sine of x back in for u. So sine x equals negative 2/3 and sine x equals 1. So in order to solve these, I have to use my sine inverse. So I know that x is equal to the sine inverse of negative 2/3. But remember, we have 2 answers. We also have to do x is equal to pi minus sine inverse of negative 2/3, because remember this value that we have right here, we called it c earlier in the table. Since it's in between negative 1 and 1, we have 2 answers. Now this one, since it's equal to 1, we only have 1 solution, and I know this is on my unit circle. So on my unit circle, where is the sine of x equal to the value of 1? At pi over 2 plus 2 pi n. So I have this solution. Now I need to find these two. Since these two are not on my unit circle, I can use my calculator. So I'm going to call this x1 and x2. So x1, if you plug sine inverse of negative 2/3 into your calculator, you get negative 0.7297. And then x2 would be equal to, let's see, we get 3.8713. And remember this, to find all of the angles, you usually add the period of the function. Now the problem is, again, that we only want the solutions from negative pi to pi. Well, pi over 2 fits. So these would be all of the solutions, but we don't want those. We only want the solutions from negative pi to pi. So to make sure I have all my solutions, if I look here, well, negative 0.7297, I know that we would be okay with that solution there. So I'm going to look at my calculator to kind of help me do this. So in my calculator, just to kind of help, so I plugged it into my y equals. On my window, I'm going to look at negative pi to positive pi, and then hit graph to see how many solutions I should have. So 1, 2, 3. So this one right here is probably my one of my solutions. So let me pause. So right here we have pi over 2, And then if I do second value, and let's do negative, so let's do the sine inverse of negative 2/3. And that gives me this value right here. So I know this one is the pi over 2 answer. This one is the negative 0.7297. Well, what about the other answer we found? Remember, it was x equals 3.8713. Well, the problem with this is notice that, well, pi is 3.14. So this is too large. So if it's plus 2 pi n, we can do minus 2 pi, and that should give me this solution right here. So let's even check that. So if I do second trace value, we're going to do the sine inverse of negative 2/3, and I'm going to subtract the period of my function so that it's on the correct interval. And notice when I did something wrong. Okay, so for some reason it wouldn't let me do the sine inverse, but if I plug in the actual 3.8713 and subtract 2 pi, notice that that gives me this answer, which is coterminal with this answer here. So this one is on the interval from negative pi to pi, so this is what I would use for my solutions instead of 3.8713. So over here, I know that my solutions are going to be x is equal to pi over 2, and negative 0.7297, and then the last one, I need to get it back up so I can see, was negative 2.4119. And so from negative pi over 2 to pi, these would be my solutions that I would have. If it asked me to find all of the solutions, then I would use these two answers. But again, if I only want it on a specific interval, I have to be very careful. And again, this one was not on the interval from negative pi to pi. So I had to subtract 2 pi from that answer to get this right here in order for it to be on that specific interval. All right, so let's go to the next question. For the next question here, we have solve the cosine of x equals sine squared x equal times sine squared x equals cosine x. For this problem here, you don't want to divide out your cosine. The reason you don't want to divide when you're doing these problems when you're solving is because then you introduce problems where you can't divide by 0, and also you could also miss solutions. So when you're doing these problems, please do not divide them out, but you can add or subtract and make it equal to 0 is what I would do. So in this case, I'm going to do the cosine of x times the sine of squared of x minus the cosine of x equals 0. That's the first step. So again, I can use algebra and factor out a cosine of x. And the reason I did that is because I got my sine by itself and cosine by itself. So the next step would be to do cosine x equals 0 and sine squared x minus 1 equals 0. So sine squared x equals 1. Both of these are on my unit circle, so I can find the exact value. So since cosine of x equals 0 is on my unit circle, I know that x is equal to the plus or minus cosine inverse of 0. So what angle gives me 0 on the unit circle for cosine? I know that it's going to be at pi over 2, or we could do negative pi over 2, so x would be equal to plus or minus pi over 2 plus 2 pi n. And then for sine, where is the sine of x squared of x equal to 1? Well, I have a sine squared there, so first I have to get rid of that squared. So in order to get something rid of something that's squared, you take the square root of both sides, so I would get the sine of x is equal to plus or minus the square root of 1, which is just 1. So now I have two more equations. I have the sine of x equals 1 and the sine of x is equal to negative 1 that I have to solve. So where do I get sine values of 1? Well, when x is equal to a value of pi over 2 plus 2 pi n, and when x is equal to negative pi over 2, or you could use 3 pi over 2 if you wanted to, it doesn't really matter, pi over 2 plus 2 pi n. So for these solutions, I would notice something right away, that if I have plus or minus my value on my unit circle, Notice that all of these answers can be simplified because I'm hitting every single here to up here, and I'm keeping going on my unit circle, so I'm hitting every single pi on my unit circle. So I can simplify this into x is equal to just pi over 2 plus pi n. So that takes care of all of my solutions. So if you can simplify it, I would suggest doing that. And I knew that the cosine of 0 could be simplified. So because of that, pi over 2 plus pi n would give me all of my solutions on my unit circle, because pi over 2 plus pi would give me 3 pi over 2, which would be down here. And then I could add another pi over 2, which would give me up here. And then I would keep on going on my unit circle. So simplified, these would be my solutions. Okay, so then let's do one last problem. So for this problem over here, notice I have -6 sine squared x plus cosine x plus 5. For these types of problems here, we can do substitution as well, but notice I have a sine squared and a cosine. So there's nothing that I can factor out to do this problem. What would be the easiest is to use your identities. So we can actually substitute in one of my Pythagorean identities. Remember, we said that the cosine squared of x is equal to 1 minus sine squared x, and also sine squared x is equal to 1 minus cosine squared x by the Pythagorean identity, sine squared x plus cosine squared x equals 1. So what I'm going to do for this problem is I'm going to use this identity right here so that I can have everything in terms of cosine. So I have -6 times 1 minus cosine squared x plus cosine x plus 5 equals 0. So I'm going to distribute the -6. So -6 plus 6 cosine squared x plus cosine x plus 5 equals 0. Combine like terms. So 6 cosine squared x plus cosine x minus 1 equals 0. And then I'm going to use substitution because I can factor this problem. So I'm going to say let u equal the cosine of x. So if I do that, I get 6u plus u, so 6u squared, sorry, plus u minus 1 equals 0. And I know that this factors into 3u minus 1 and 2u plus 1. So then I can now do u is equal to 1/3, or u is equal to negative 1/2. Now for these problems, let's say you forgot how to factor this. Even if you forgot how to factor, you can use the quadratic formula to do this as well. So just to show you, I can use a quadratic formula. I would get u is equal to, my b value is 1, so -1 plus or minus the square root of 1 squared, which is just 1, minus 4 times a, which is 6, times c, all over 2 times a, which is 2 times 6. So if I simplify this, u is equal to -1 plus or minus the square root of 25 over 12, which is equal to -1 plus or minus 5 over 12, which means that u would be equal to, if I do -1 plus 5 divided by 12 and -1 minus 5 divided by 12, notice I would get 1/3 or -1/2, which is the same as what I got when I did factoring. So again, even if you forget how to factor, use the quadratic formula to find your solutions. Now the last step that we would have to do is substitute my cosine of x back in. So for this one, I get the cosine of x is equal to 1/3. So to find my solutions, I do x is equal to plus or minus the cosine inverse of 1/3 plus 2 pi n. So when I do this on my calculator, because it's not on my unit circle, I get x is equal to plus or minus 1.2310 plus 2 pi n. And then I'm not done because remember I still have to do this solution up here. So I get the cosine of x is equal to -1/2. That is a value on my unit circle. Since it is a value on my unit circle, I can use my unit circle in order to help me. I know I would be in the second quadrant or the third quadrant to get a negative x value for cosine, because remember cosine is your x, sine is your y. So if I want -1/2, I would be up here. So I know that's going to be at 2 pi over 3. So in this case, x would be equal to, and I can do plus or minus that answer, so plus or minus 2 pi over 3 plus 2 pi n. And if you don't want to write plus or minus your answer, if you actually want to find the other cosine value that we have on our unit circle, where I have the cosine of x equal -1/2. So if you wanted to use 4 pi over 3 plus 2 pi n and 2 pi over 3 plus 2 pi n, that's okay. They're still correct. So either way, I just find it easier to do the plus or minus for cosine since that's what we had. If it was sine, remember we'd do pi minus our answer. So these are our solutions to this equation. So we can use factoring and algebra. We can use our identities to help us. And again, just make sure you don't divide out by your trigonometric functions, because then it introduces extraneous solutions and you might miss solutions. So just to go back to the beginning, so this is kind of a table which helps us find our solutions. So remember, if you're in between -1 and 1, you have two solutions for sine. One's the sine inverse, one's pi minus the sine inverse plus your period of the function. When it's equal to 1 or -1, you have one solution, and above 1 or -1, no solutions. Cosine, two answers, plus or minus your cosine inverse plus your period of your function. 1 and -1 have one solution, and tangent always has one solution plus pi n. So make sure you bring this with you to class. I know we didn't do that last problem, number 8, so if you wanted to try that last problem, you could. I think the answer or solution to that might be in the book.